Topic 2.5 is about discrete versus continuous graphs. In order to start, we're going to complete the bell work. So the domain, remember, is your x values. X's go from the left to the right. So the farthest left value we have is negative 1, 2, 3, 4, 5, 6, 7. So negative 7. At negative 7, there is a filled-in bubble there, so it's going to have a line under the inequality. X goes in the middle, and then from X in the positive direction, we have 1, 2, 3, 4, 5, 6. Again, we put the line under the inequality because the bubble is filled in at 6. Range is your Y's, so I'll do this in a different color. Your range is your Y's. Your Y's go from the bottom to the top. So looking at the bottom, the lowest Y value and the highest Y value. The lowest Y I have is 1, 2, 3, 4, 5, and it's negative because we're going down. At negative 5, there is a value for Y, so I will include the line. Same thing up at the top with this Y. There is a value up there, and it's at 1, 2, 3, 4. So the domain is my X's from left to right. My range is my Y's from bottom to top. Discrete and continuous can be used to describe domain and range, and here are the differences between the two. So with discrete, a set of data is said to be discrete. If the values belonging to the set are distinct and separate, so they are unconnected values. Okay, so they are things that cannot be split up because they're already split. Okay, an example of this could be feet. Most of us have 2 discrete feet. We don't have a foot and a half. Shoe sizes would be another example of discrete data. You have a size 5, 5.5, 6, 6.5, 7, 7.5. You can't buy shoes in a 5 1/4. You can't do that. So discrete data is counted. So things that you can count, like feet sizes, 5, 5.5, 6, 6.5, etc. So discrete, in a graph of a discrete function, they are only separate. So they're only separate distinct points that are plotted. And only these points have meaning to the original problem. For example, going with shoe sizes, if you were to graph everyone's shoe sizes, they would all kind of cluster, but we wouldn't have a continuous line for shoe sizes. We would have various dots based on shoe sizes. They would be very distinct points based on everyone's shoe size, and they would have meaning to the original problem, but anything outside of what we've plotted would not make sense for that problem. So looking at continuous, a set of data is said to be continuous if the values belonging to the set can take on any value with a finite or infinite interval. So these are things that can have in between values. So an example would be when you measure things, you can have 1 millimeter, 2 millimeters, you can have 2.0002 millimeters, you can have lots of in-between measurements. Continuous data can be measured. So discrete is counted, but continuous is measured, so you can see the changes. In the graph of a continuous function, the points are connected, like through a line, or with a continuous line, since every point has meaning to the problem. So with discrete, we have very succinct points. Continuous is a line or a set of lines that can show us where we're going. So looking at the scenarios, they ask us to decide if it is going to be discrete or continuous. So 1 through 5, a stack of coins would be discrete. You can have a stack of 10, 11, 12, but you can't have a stack of 10 and a half. So you would have very distinct counted separate points. Same thing with a bag of apples. You could eat part of an apple, but that would still be counted as one apple. So you would have 1 apple or 2 apples or 3 apples. You wouldn't have 1.375 apples. Now with minutes, you can have 1 minute, a minute and 10 seconds, a minute and 11 and a half seconds. So you can have continuous time. Time is continuous. We can measure it discretely, but it is continuous overall. A dozen eggs, again, you can't split those up. You have a dozen, you have 11, you have 10, you have 9, 8, 7, 6, 5, 4, 3, 2, 1. You can't have 1.5 eggs. If you notice, most recipes call for full eggs. The area of a circle would be continuous because you could move that circle, move that radius, and your area would grow. If you move your radius like 0.0001 bigger, then your area would be affected by that and can range continuously. Part 6, the distance from here to the moon would be continuous because the distance, you could be here, you could be a little bit closer, you could be a lot closer, you could get in a spaceship and hit the moon. So there's distance. It's not like if you go to the moon, the space shuttle takes leaps and bounds. It flies continuously. Pearls on a necklace would be discrete because you have pearls and you don't have pieces of pearls on a necklace. The number of people in the room is again discrete because you can't have parts of a person. Even if you have a dead body, that's still a person. I know it's morbid, but you have 10 people in a room, 12 people in a room, 50 people in a room, 175 people in a room. They can be counted. They do not need to be measured. Temperature would be continuous. Temperature is continuous because as we go throughout the day, the temperature increases steadily. Maybe it's 91 degrees, then it's 91.5, then it's 92, 92.5. Also, it's something that we measure, not count. We measure it. And then shoe sizes, as we talked about earlier, is discrete because shoe sizes, you can only buy certain sizes. You can't order a 5.372 because that's the size of your foot. You order a 5 or a 5.5. Very discrete sizes. So discrete and continuous data look different on a graph as well. Remember, discrete is things that do not connect, whereas continuous does connect. So looking just for discrete versus continuous, 11 would be continuous because we have lines that are going on for forever. 12 would be discrete because we have succinct separate points. Whatever number this is. 13 would be continuous and 14 would be continuous because these are lines. Domain, again, is your x values. Now here, if these lines go on forever and ever and ever and ever and ever and ever, my domain is going to be all real numbers because I could plug in any x, and even though it's not on my graph, I could still figure out what that x value would be. So my domain here is going to be all reals. The range for this is my y's. So remember, with y's, we go bottom to top. This one, the bottom is -2, and then it is increasing from there. So we have -2, we have y, and y is getting greater than or equal to -2. So for 11, we have a continuous graph. My domain would be all reals. My range would be y's are greater than or equal to -2. Problem 12, because this one is discrete, we have to put the little braces around it because we have very succinct counted lines, or points, that are on this. Looking at my domain, remember the order doesn't matter, just make sure you catch all the x's. So this would be -3, -2, -1, and both of those are +1. And note that I'm just putting these little check marks by it to make sure that I get all of them. You don't have to put the little marks. I just want to make sure I don't miss anything. And then my range is my y's, so I put my braces again because it's discrete data. Looking at the bottom, I have 2 down here at -2. This one's at a +2, +3, and +4. So look at the difference between 11 and 12. 11 is continuous and has inequalities for my domain and range, while 12 is discrete and I have braces of very succinct points for my domain and range. 13, looking at this domain, my x's are going to keep going for forever and going for forever, so that would be all reals again. Very similar thing with my y's. Even though this looks like it's leveling off, it would keep sloping that way, and we can't see where it ends, so we know that it means all reals. Even if you're not for sure if it's sloping or not, it's probably going to be all reals unless you have end points or very succinct stopping points like we do here. And then on 14, my domain, so this is the point, -4, -1 right here. And it's an open bubble, so I need to keep that in mind. When I frame my line, so remember we make a little picture frame and put our arrow in between. My y's are going up, so my y's are increasing. Sorry, I need to do that in this color. And my x's, as they move to the right, are also increasing. So both of these would be greater than. So my x is going to be getting bigger than or equal to -4, and my y's are going to be getting bigger than or equal to -1.